Okay, so now we're going to solve quadratics by completing the square. And so the previous section will be used heavily here where we were solving using the square root property. So what we're going to do here, I'm going to go over this in just a second, but I want to scroll down, just look at this real quick. So if you look at this first problem right here, if you were asked to solve this, you would think, well, maybe I could factor it, and you would set it equal to 0 like this, we've done previously, and you would do the A and M method, right? What adds to -2, but the two numbers multiply to +2. And you could try and try and try and try, and you'd have a really hard time because those numbers, the answers we're going to eventually get are going to be irrational. And so factoring is actually not what you want to do here. It's pretty much impossible. So that's where the completing the square is going to come in. So before we do that, we want to talk about this pattern we want to develop in order to be able to do completing the square. And what we're going to need here is we're going to need these things called perfect square trinomials. And so we talked about that in our very first section in notes. And so there's a pattern for a perfect square trinomial, and the pattern is going to be right here. And what the pattern is that the third value right here, the third term, the constant, is going to be half of the middle coefficient raised to the second power. Okay? And that's true for both of these right here. The only difference is one has a plus, one has a minus, but this one always is plus right here. So always be plus. And then what happens is that will factor into x plus half of that middle coefficient and then to the second power. It'll be a little bit easier to understand once we do a couple examples. So what we have to do here is figure out what is that constant term that should be here to make it a perfect square trinomial. And that's pretty easy to do. You just take half of this coefficient and then square it. So half of that is 5. 5 to the second power is 25. And then this factors into x plus 5, x plus 5, or what we're going to want to do is write it as x plus 5 to the power of 2. And so you can see that it followed that pattern here. The 25 was half of my middle coefficient raised to the second power. And then it factored into x plus half of that middle term right there, 5, and then all raised to a power of 2. And so that's a pattern you'll want to pick up on. It'll make the process easier as we kind of go through these. So looking at another similar example to this, the only difference is we have a minus here, okay? So half of that is -7, but when you square -7, it becomes a positive 49. So it'll always be positive right here. And then you can see if you're to do the A and M method or whatever, this factors into x minus 7, or x minus 7 squared. And so once again, you can see that it follows that pattern. If you have a perfect square trinomial, then it's going to be x. In this case, it was minus because we had a minus as our middle term. And then half of the coefficient right there. So x minus 7 and then squared. Okay, so what we're going to do here as we move forward is we're going to manipulate these expressions to where the left-hand side is a perfect square trinomial. And once we manipulate the left side to a perfect square trinomial, they're actually going to look a lot like the problems we just got done doing in the previous section of notes. Okay, so this is the way I like to do it, and you can read through these directions if you want, but I'm not going to read from the slide right here. But pretty much it says as much what I'm going to do here. So what I like to do is I'm going to rewrite this x squared minus 2x, and then I like to put plus blank because I got to put in that constant there to make a perfect square trinomial, then equals 2, and then I'm going to put a plus blank over here too, because the difference is up here I had an expression and I was just playing around trying to, you know, investigate these perfect square trinomials. Now I'm actually trying to solve something. So if I do something to one side, if I introduce a value, I have to introduce it to both sides to preserve the equality. So here I go. I'm going to take half of -2, which is -1. -1 squared is +1. So I'm going to add a 1 here, and I'm going to add 1 here. Now what I have on the left side is I have my perfect square trinomial. So this will factor into x minus 1, but we're going to want to go ahead and write that as x minus 1 squared. The right side will be 3. 2 plus 1 is 3. Now, like I said, now it looks pretty familiar from the previous section of notes we were working on. So I'm going to go ahead and square root both sides. I'm going to use the square root property. Got to put that plus minus. So we get x minus 1 equals plus minus square root of 3. And then the last thing we want to do here is go ahead and add 1 to both sides, and we just wedge it in front like we did on those other examples. So 1 plus or minus the square root of 3. And just realize there is two answers. 1 plus the square root of 3, 1 minus the square root of 3. And once again, if you were to plug that into this equation up here, it would equal 2. If you were to plug that in for x right here in those two spots, okay? So if you want to play around with that later, you can. All right, let's look at another one of these. Okay, so on 51, uh, what's going on here is it's set equal to 0. You might think, oh, maybe I could do the A&M method, and you could look, and you could, what multiplies to give you negative 11, but adds negative 6, and you're going to have a tough time with that. It's going to be something similar to our previous answer over here, so you're not going to be able to figure that out. So what we're going to do is we're going to open up this spot right here. So I'm going to add 11 to both sides. So then I'm going to have x squared minus 6x plus, and then I'm going to put that blank there, equals 11, and then I'm going to put another blank, just so I don't forget that I have to put it on both sides. So now I'll take half of this, which is negative 3, raised to the second power is 9, so I'm going to add 9 to both sides. So I add 9 to both sides. So the left side is perfect square trinomial. This is going to factor into x minus 3, so I'm going to put x minus 3 squared, okay? And then the right side is going to be 20. So now we'll go ahead and square root both sides, plus minus, okay? So we're going to get x minus 3 equals plus or minus. Now, square root of 20, I can go ahead and break that up into a perfect square. And so let's see, I believe 4. So I'm going to break that up into 4 times the square root of 5. So I can go ahead and do that. I can break that up. And I can go ahead and square root the 4. So now we're going to have x minus 3 equals plus or minus 2 square roots of 5. And then the last thing we're going to do is add that 3 to both sides. And we'll be good. X equals positive 3 plus or minus 2 square roots of 5. So once again, we have two answers that are there. Okay, so I got a couple more. Probably somewhere we'll come up with some I's as part of our answers. Okay, so let's see, looking at 53 right here, I'm going to start by subtracting 1 from both sides, so that cancels out. So let's see, we're going to have x squared plus 4x plus my blank equals negative 1. Okay, and so let's see, half of 4 is 2, 2 squared, oh yeah, put my plus blank over here. Um, half of 4 is 2, 2 squared is 4, so I got to add 4 to both sides. So we'll add 4. Okay, so I do have a perfect square trinomial right here. This is going to be x plus 2 twice, so I'm going to write it as x plus 2 squared equals negative 1 plus 4 is 3. This one looks pretty basic. This one looks pretty simple like the very first one we did. So we'll square root both sides, plus minus x plus 2 equals plus or minus square root of 3. And then we'll subtract 2 from both sides. X equals negative 2 plus or minus the square root of 3. So that one was fairly simple. Okay, and it just takes practice. I don't want to act like the whole thing's easy. It's quite a process, but once you do it enough times, it gets pretty simple. Okay, looking at 55, we're going to move that 25 to the other side. So we'll get x squared plus 8x plus blank equals negative 25, and then we'll put a blank over here. Okay, so half of 8 is 4. 4 squared is 16. So we'll add 16 to both sides. Once again, the left side's a perfect square trinomial. That would factor into x plus 4 squared. Now the right side, this will be interesting. It's going to be a negative 9. Now that won't give us too much trouble though, but we are going to get those complex solutions, and what I mean is we'll have the imaginary values with it, the I. Okay, so let's see what we have here. So this will be x plus 4 equals plus or minus, and then this is going to turn into a 3i, okay, because of the negative with the 9. And then we'll go ahead and subtract 4 from both sides, and that will be it. So x equals negative 4 plus or minus 3i. Okay, I have one last example we're going to look at, and I'll just tell you up front, this one's going to be a little messy, and it's kind of done on purpose to kind of prepare you for our next lesson, where we'll look at another approach that we might want to use. So by the way, completing the square, we've been solving equations. It's used for other purposes, especially in pre-calculus. So this is kind of a skill that you'll use in other courses. For this course, it's more for kind of investigating and seeing how it can help you solve equations, but it does have other uses. Okay, so starting on this one, I'm going to start by adding 1 to both sides. And so I'm going to have x squared plus 3x plus blank equals 1. Now, what's going to make this one challenging compared to the others is my middle value is odd. It's odd. So that value I'm supposed to get over here, my third term, I got to take half of that and square it. It's really not going to be that big of a deal, but I'm assuming most of y'all probably aren't crazy about fractions. And so it's going to cause us to have to deal with fractions, and it does make the process a little bit more challenging and more likely that you could make a mistake. Okay? So what I'm going to do is I'm going to come up here. So what I want to do is, this is known as your B value, by the way. Okay, this is known as your C value, and this is known as your A value. And we'll talk more about that later on in other sections. Okay, so that C value by definition, if you look at our definition at the very beginning, it's supposed to be half of B raised to the second power. Okay, so let's go ahead and do that. So I'll take half of 3, and then I'm supposed to square it. Now, when you square a fraction, you square both parts. You square the top and the bottom, so that'd become 9 over 4. So I'm going to have to add 9 over 4 to both sides. I'm going to have to add 9 over 4. And like I said, you're probably not too crazy about this. It'll all work out fairly nicely, but you just have to be careful with this. So from the beginning, I've been kind of harping on making sure you're following the pattern. And what you'll notice is the pattern is when you factor this, it's always x plus half of this, x plus half of this squared, right? X plus half of that squared, x plus half of that squared. And so that's going to be the pattern that we're going to follow here. And that will make this a little bit easier. So this factors into x, and then half of this, so that'd be plus 3 over 2, and then squared. So that's what this factors into right here. Okay. Um, and then on the right side, we're going to want to add these together. So I'm going to have to get an LCD of 4. So what I'm going to do is I'm going to manipulate that 1. I'm going to change that 1 into a 4 divided by 4, because 4 divided by 4 is 1. Okay. And so then we're going to add 9 over 4 right there. And I know I'm going kind of fast, so if you need to pause, rewind, and make sure you kind of grasp what I did on the left side here. I was more or less just following a pattern that had been developed with these. Okay, so now I can go ahead and combine these right here because I have a common denominator. So let's have x plus 3 over 2 squared equals, and this is going to add up to 13 over 4. Okay. And then what we'll do here is I'm going to go ahead and square root. Got to put plus minus right there. Okay. And so let's see. We're going to get x plus 3 over 2 equals plus minus. Now, when you square root a fraction, here's a property. Square root of a over b is the same thing as square root of a over square root of b. So you can break it and square root them separately. Well, the square root of 13 is a decimal, so I'm just going to leave it like that, square root of 13. Square root of 4, that's 2, so I can go ahead and complete that. So I square rooted 13 divided by 4. I square rooted top and bottom separately. Okay. The next part we're going to do here is we'll go ahead and subtract 3 over 2 from both sides. We're going to subtract 3 over 2 from both sides. I'll write this up here so we can see everything on the same screen. And so that will cancel out here, and I'm going to be left with x equals negative 3 over 2 plus or minus the square root of 13 over 2. And you know, that's a pretty good answer. But the computer might be a little picky. They might say, you know what, you've got a common denominator. We can bring that together. So what we'll do is we'll go ahead and bring this together as negative 3 plus or minus the square root of 13 all divided by 2. And there we go. And there's your two answers to this, okay? So, yes, I know this one's fairly complicated, but it's a good way for you to practice your algebra skills because you need to know how to, you know, get common denominators and deal with some of this messy stuff. So it's good practice in that sense, okay? The next section will kind of show you another way of solving these that might make things a little bit easier than what we had to do here. But go ahead still, you know, when you're doing your homework, go ahead and use this method. But as they get worse, because they will get worse after this section, I have another approach that we're going to use, okay? Um, all right.